Let's see how we can query related records using the ArcGIS API for Python. Open up the query related records.py script from the data folder. The feature layer object has a query related records method that allows you to do just that. Back in the relationships section, we set up relationships, and one of those relationships is where we related a trail viewpoint to a trail point review, and the cardinality was 1 to many. One trail viewpoint can have many reviews. In this lesson, we're going to see how we can use the feature from the origin dataset and query the destination dataset. Let's first head over to the documentation for the feature layer object query related records. Here we have the documentation for the query related records from the feature layer object. There are 3 required parameters: object IDs. This is a required string and it is the object IDs of the table or layer to be queried. This is the origin data. We then need the relationship ID. So this method needs to know the ID of the relationship to be queried. That is the relationship between our trail viewpoints and our viewpoint reviews. And then the out fields that you want returned. This is the list of fields from the related table or layer. The rest of the parameters are optional. We're going to set the return geometry to false because we are querying a table. That is, the destination dataset is a table. And you can also use a definition expression to return or limit what is returned from the destination table. In our example, we'll use the 3 required parameters along with the return geometry. If we scroll down the bottom, we can see that this returns a dictionary of the query results. So let's head back over to our Python script. Up top, I am importing the JSON module from the standard Python library, and this will allow us to print that dictionary that is returned from the query related records in a more easier to read fashion. First, access ArcGIS Online using our GIS class and supplying our home string. We'll assign our GIS object to a variable called AGOL. Then access our GIS object content manager and use the get method supplying in our feature service item ID, which I'll paste in now. The get method will return an item object that will assign to a variable called item. From the item object, we can access the layers property, which is a list of feature layer objects. We're interested in the first feature layer object that represents our trail viewpoints, and we'll assign that feature layer object to a variable called FL. First, going to print the feature layer properties relationships property to screen so I can see what the relationship ID is from our trail viewpoints to our viewpoint reviews table, because we need that relationship ID for the query related records method. I'll run the script. Take a look down at the bottom. We have 2 returned from the list of relationships. First one is from the trails to the views. We are interested in the views to the reviews, and we can see that has an ID of 4. So this is the relationship ID we will use with the query related records. I'll comment out printing the relationships to screen, and I will open up our example. We first use the feature layer object getUniqueValues method to return a list of all the object IDs for our trail viewpoints layer. We'll assign the list of object IDs to a variable called OIDs. We're then going to get the related records dictionary. We call upon our feature layer object and we use the query related records method. We have our first required parameter, and that is object IDs. I'll set that to equal a string. It needs to be a comma separated string of OIDs. I'll put the comma in between my double quotes, and then I'll use dot and the built-in join function. And then I'll use comprehension here to cast the OIDs to a string. So for OID in OIDs, return the OID as a string. And this will look like this when it's finished. 1, 2, 3, 4, 5, etc. The reason we're casting the OID to string here is because the join is a string function, and if they are numerical, it will not inject it into the string. We then set the relationship ID, and we know that is 4. That is the relationship between the trail viewpoints feature layer and the viewpoint reviews table. We set our out fields, which is the final required parameter. We're only interested in one field here, and that is the rating. And we'll set return geometry to false. I'm going to use the json.dumps method and supply in our related records, which is the dictionary returned from the query related records method, and we'll set an indent of 4. I'm just going to comment out the rest of the code for now, and I'll run and print that related records dictionary to screen. Let's take a look at the returned dictionary. See here, it is a dictionary that's returned. We have a key in here of fields, and that is a list. That list is a list of dictionaries. Scroll down, we can see that there is one dictionary in that list. And if you take note, it is the rating field, the only field that we added to our query related records method. It has returned the definition for that field. The next property is the related records groups, which is also a list of dictionaries. Take a look at the first dictionary. It has an object ID of 2, and it has a related records list. This is showing that there is one related record that has a rating of 10 for object ID 2. So object ID 2 is from the origin feature layer, which is our trail viewpoints, and this rating of 10 is coming from the trail viewpoints reviews. We go down to the next one. Our object ID of 4 has a rating of 6 in a related record. Now when we hit object ID of 5, you can see that our related records has 2 entries. It has a rating of 8 and a rating of 7. I got that wrong. It actually has 3 entries. We can see another rating of 9. So you can see how the related record information is being returned. We only asked for the rating. So for each entry in the related records list, the attributes property only contains the rating field that we asked for in the query related records. I'm going to head over to ArcGIS Online and take a look at object ID 5. Here I have the trail viewpoints dataset, and we can see here we have our object ID of 5 for sleeve bloom. I'll highlight that and scroll across, and we can see the 3 related records here for the views and reviews. I click in, we can see the viewpoint ratings of 8, 7 and 9 that match what we returned from our query related records method. Head back over to the Python script. I'll comment out printing the related records to screen, and I'll open up the next part of the workflow. We're going to get a viewpoint dictionary here that is the OID and the viewpoint name from our feature layer, which is our trail viewpoints. We're using dictionary comprehension. So for each feature returned from our feature layer query, which is a feature set, we're going to get the feature attributes object ID value and the attributes viewpoint name value. The object ID will be the key and the viewpoint name will be the value. It's going to print that viewpoint dictionary to screen. Let me run the script so we can see what that dictionary looks like. And we can see our object ID of 1 is our FDM park view, our 2 is our FDM statue, our 3 is our made up battle site, and so on. We're going to use this dictionary along with the related records dictionary to print some information to screen. I'll open up the rest of the workflow and I'll comment out our printing that dictionary. We're going to iterate over the related groups, which is a list. We take a look down below. We have the dictionary returned from the query related records, and we have a related record groups property, and that is a list. We're going to iterate over each dictionary in that list. Each dictionary represents the related record information between our trail viewpoints and our reviews. So for each relationship group in the related records groups, we're going to get an average rating. To get the average rating, we need the sum of all the individual review scores and divide them by the amount of the review scores. We use the built-in sum function for Python, and in here we are going to use list comprehension. So for each related record, which we'll call OR, in the rel group related records property. So if we look down below, each related record group is a dictionary and it has a related records property. And we are interested in the attributes rating. So go back up to our list comprehension. And we're interested in the OR attributes and rating. Sum function along with our list comprehension will return the sum of all the review scores for a single trail viewpoint. We then want to divide that by the length of the rel group related records. So if we take a look down below, our object ID 2 only has 1 related records, as does 4, but our 5, as we saw, has 3 related records. So 8, 7 and 9 will be summed and then divided by 3 to get the average rating. We're then going to print the rel group object ID to screen. So if we take a look at our group, object ID of 5 will be printed to screen. We're then accessing our viewpoint dictionary using that rel group object ID. And as we saw, our object ID will produce sleeve bloom. And then we are also printing the average rating. So let's run the script. Our script is complete and we can see the output printed to screen. Object ID of 2 is our FDM statue with an average score of 10. 4 is our made up waterfall with an average score of 6. 5 is sleeve bloom with an average score of 8, and so on. Now, not all the origin features are listed here. If they do not have any related records, they will not show up here. You successfully used the query related records with the ArcGIS API for Python to retrieve information from a destination table related to the origin feature layer. Make sure to continue on to the next video in this series and also make sure to subscribe. Take care.